I will try to develop the expression for the differential amplifier. So this is the circuit arrangement, and it's an operational amplifier, so there is no current into the terminals. So let's call this point VA and this point's voltage VB. And if we apply KCL at VA or point A, we can see that the current that is coming here, there is no current into the terminal, so the same current will go this way. So I can write the expression like VA minus V1 minus VA over R1, this is the current that is going this way, will be the same current which is the leaving current at point A, if we will, this point, this one. So that will be VA minus V naught over R4. So I can rewrite V like that, VA over R1 and VA over R4 minus V naught over R4. So I can write this one V naught over R4, this part, the last one on the left hand side, and then this can become VA 1 plus R1 plus 1 plus R4 minus V1 over R1. And if I rearrange this one even more, I can write, I will go here, R4, this can be VA, so R1 R4, R1 plus R4 and minus V1 R1, and if I multiply both sides by R4, it becomes VA R1 R4 over R1 minus V1 over R1, and this one can be written as 1 plus R4 over R1 minus V1 over R1. So that's one expression, one equation we can have. And if we write the same thing, do the same thing at point B, which is this one, we write KCL here. The current that is going here is the same current that is coming down. No current is going into the positive terminal. These two currents are zero. So no current into the op-amp terminals, of course. So this one can be written V2 minus VB. So I will write V2 minus VB over R2. That's V2 minus VB there over R2, this resistance, is equal to VB over R3, which is the current going down. So VB over R3. So this one can be written V2 R2 minus VB over R2 equals to VB over R3. So if I rearrange this one like before, like the previous one, so this can be VB 1 plus R2 plus R3, and this can be written V R2 R3 R2 plus R3. So V2 is VB R2 plus R3 over R3. So I have multiplied both sides by R2, so that can be also written 1 plus R2 over R3, yeah, like that. So this one can be written as like that as well, 1 plus R2 over R3. So this is my expression of VB, and what I will do, I will, in my differential amplifier expression, the final expression, I just want it in terms of V0, the applied two voltages, and the V1 and V2. So V0 is the output voltage in terms of V1 and V2. So I want to get rid of VA and VB. So this is the expression of VB. I have found this one. I will substitute this expression here in the first one, which is this expression V naught. So in this equation, sorry. So now we know that VA is equal to VB because there is no voltage drop between the two terminals. So VA is equal to VB. So basically this can be written as VB as well. So that I will do. So instead of VA here, so let me just rewrite this equation. V naught is equal to VA there, and 1 plus R4 R1. So VA 1 plus R4 over R1 minus V1 over R1, I guess. And instead of VA, I can write VB, and this is the expression of VB. So I can write V1 over 1 plus R2 over R3 times 1 plus R4 over R1 minus V1 over R2. And sorry, this one will be V2. This is a mistake done there. This is V2, so this will be V2. So this is V2 there, sorry, and this is V1. So that is there. Now what I can do, I will just get the R4 over R1 ratio out. So what I will do, I will write here R4 over R1. I will take that out. I have figured out one mistake here, which I will correct now. This equation, when I multiplied by R4 here, I forgot to multiply in this term. So it will actually have R4 over R1, not only V1 over R1. So V1 times R4 over R1. So that one I will correct now. R4 over R1, R4 over R1. So just this original, the first equation of V naught in terms of VA and V1. So here I have corrected it now. So I am taking, since there is R4 and R4 over R1, sorry, R4 over R1 ratio there, I am taking the R4 over R1 out. I will just show in a minute. So this is becoming V2. It's just the other way. So it's becoming R1 over R4. And there 1 plus R2 over R3 minus V1 R4 over R1. Now if we have the expression R1 over R4 is equal to the ratio, sorry, R1 over R4 is equal to R2 over R3, if we have that balance, the values of the resistances, if they are like that, then these two terms become same. So this term I will use black maybe. So this one and this one, so they can be cancelled out. If R1 over R4, the ratio R1 over R4 and R2 over R3, that ratio the same, if they are the same, then these two will be the same, so we can cancel it out. So our expression now becomes V naught R4 over R1, that stays there because we are just talking about the ratios there, and V2 minus R4 over R1 V1. So we can write it R4 over R1 V2 minus V1. So this is the expression of the differential amplifier. And what we have here is we have an output as the difference of two input voltages. And if R4 is equal to R1, if they are the same, we have just a subtractor. So V2 minus V1. Basically we can make it a subtractor. We can also make it a the difference amplifier, differential amplifier or difference amplifier, whatever. If we have the ratio, like if R4 over R1 say they are 10, so R4 may be 10k, R1 1k, whatever, then we will have 10 times amplification of the difference voltage. So whatever V2 minus V1, that will be amplified by, that will be 10 times amplified if we have that ratio, and we can have them equal to make it a subtractor, or we can make it a difference amplifier by choosing the appropriate resistances. So that's the expression. I did this video long ago, but anyway, I'm making it again. So yeah, thank you.